Hi students, welcome to another session, and today we are going to start from four mathematics topics. As you can see in our cover part, we have basic mathematics for secondary school students who form 4. And so the coverage is going to be basically on Form 4 topics. So in Form 4, according to the current syllabus we have about 80 topics. You can see chapters, chapter 1 up to chapter 8. So, chapter 1, the first topic is coordinate geometry. The second topic is areas and perimeters. The third topic is three-dimensional figures. The fourth topic is probability. And the fifth topic is trigonometry. You go to sixth topic is going to be vectors. We have chapter number 7, matrices and transformations. And the last one is linear programming. So as we are starting, of course, we are going to start with the first topic, and the first topic is coordinate geometry. And in coordinate geometry, dear students, it's important to understand that we are going to learn uh, so many subtopics. The first subtopic being the gradient of straight line. Then after that, we are going to go to equation of a straight line, then the midpoint of a line segment. Then we'll be going to distance between 2 points on a plane. We are going to consider parallel and perpendicular lines. And after all these coverage, we are going to be comfortable saying that the topic of coordinate geometry is over. And I'm sure after this coverage, we are going to check questions, and questions will be solving. We include actually questions even from NECTA past papers. The questions we'll be solving will include also NECTA past papers. So I think uh, you are going to be exposed to very important concept where you will be able to master the concept of coordinate geometry, and specifically here, even we will be checking how questions are coming from national exams. Apart from NECTA questions, but also be able to see questions from other sources, of course. And then after that, the topic will be over, and I'm sure we will proceed with the next topic in our coming sessions. So to start, dear students, today we are going to focus only on the first part of our coordinate geometry. I'll be giving you an introduction. Then after that, we are going to go to a gradient. So here we go. So I think before we go to gradient, it's important you guys to understand, the introduction of coordinate geometry. So coordinate geometry is the study of geometry which describes the link between geometry and algebra through graph involving curves and lines. So understand that in algebra we are focusing actually on graph, and also these graph actually will involve curves, and we are going to see also lines. It is the part of geometry where the position of point on the plane is located by using coordinates. And when you say coordinates here, you can just simply refer to coordinates x, y. So in this chapter, you will learn how to locate the coordinate of a point on the xy plane. You are going to learn actually how to allocate points on xy plane. You are going to see that. You are going to learn how to find the gradient of straight line. You are going to derive general form of the linear equations. You are going to solve problems involving linear equations. You'll be able to determine the coordinates of midpoint of line segment and solve problems involving midpoints. We'll also learn how to derive distance formula. You'll be calculating actual distance between 2 points on a plane, and you're going to be able to solve problems involving parallel and perpendicular lines. The competences developed will be applied in various real-life situations such as land surveying, map projection, location of air transport, forecasting in building constructions, human resource management, farming, and many other fields, dear students. So let us go to gradients direct. There is an activity, but I would prefer to go straight forward to going to talking of gradient, because this is the concept actually you already know from Form 1. So what I'll be doing here, I'll be taking this simple graph. We have, I'll be taking it actually to another note where over there I'm going to show you how we can find the slope of a straight line. So remember, slope, dear students, we said that slope or gradient, all these, they are used interchangeably. So slope, you'll be taking change in y over change in x. And talking of change in y over change in x, we'll be considering 2 points, points A and point B. Point A being x1, y1, point B being x2, y2. And so talking of change in y, we'll be saying that change in y over change in x will be y2 minus y1 over x2 minus x1. It is also possible, of course, it is also possible to consider that actually change in y over change in x, we can take y1 minus y2 over x1 minus x2. So this is actually definition of the slope. We'll be denoting actually the slope of a line by using letter M. So how do you find the slope? Such simple approach that the slope is going to be change in y over change in x, and we have seen that with change in y over change in x, we have the slope already, dear students. Okay, so after we have seen the way we can calculate actually the slope, now you are even in position to find the slope of any line, as long as you are given actually 2 points. You can call these points point A and point B. So we are going to dive into example, and with this example here, you can see that this example, with this example, let us see how we can find the slope. So with this example here, dear students, find the gradient of the straight line joining points A and B. So you can just consider point A 4,8, and point B, which is 5, -2. You can consider to be x1, y1, and this is x2, y2. So the slope, we know that slope, dear students, is change in y over change in x. We simply say that it is y2 minus y1 over x2 minus x1. So the slope m will be y2, which is -2, minus y1, which is 8, divided by 5 minus 4. So you have -10 over 1. So the slope is going to be -10. The slope is going to be -10. So we can conclude that the gradient, the gradient or the slope is -10, dear students. So as I told you that being given 2 points, you are always in position to calculate the gradient of a given, the gradient actually over a given line. You can be given actually also a question like this one here. Let us dive into this example. Calculate the gradient of line PQ. Calculate the gradient of line PQ. So how do we find the gradient of line PQ? The gradient of line PQ, dear students, you'll be coming to our notebook here, and from here we can see that, so we have point P, which is 1,3, and point Q, which is -3, -2. So you can consider this to be x2, y2, and you can consider this one here to be x1, y1. So we know that our gradient is change in y over change in x is y2 minus y1 over x2 minus x1. So it means the gradient, dear students, will be y2, which is 3 minus -2 divided by 1 minus -3. So this is 3 plus 2 over 1 plus 3. So the gradient, dear students, will be 5 over 4. So that is the gradient according to the given question. So dear students, that is how we are calculating the gradient of a given line. And so that is basically how we are calculating gradients of any given 2 points. Of course. So this is just introduction session. The coming session, we are going to see how we can find the equation of the straight line you're going to be in position to determine how to find the equation of the straight line. So until that time, then do as many questions as possible. As long as you have 2 points, let it be point A, x1, y1, and point B, x2, y2, you are in position to find the slope or the gradient, which is actually y2 minus y1 over x2 minus x1, or you could say that the gradient is y1 minus y2 over x1 minus x2. So that is all about today's session, dear students. I wish you all the best in the process of learning mathematics. I hope this session was beneficial to all of you. So until next time, continue learning mathematics, enjoy the process, make sure you solve as many questions as possible. See you then in the next session.